Hi, my name is Eric Petz. I'm the head of marketing at Emergent Vision Technologies. I am standing in the middle of a 36 camera Gaussian splatting array. So what does that mean? 36 cameras, all recording at 12.4 megapixels, and then rendering into a 4D Gaussian splat. Essentially a 3D video that you can manipulate after filming to go from any perspective. The cameras being used in this 4D GS setup are our Aeros 10 Gigi series. This is an extremely compact camera. We're talking 29 by 29 millimeters by only 44 millimeters long. So for creators that are looking to create wide arrays of these cameras, it's very cost effective, it's easy to hook up to your network equipment and get started with these volumetric capture techniques. This 4D Gaussian splat is stitched together using our eCapture Pro software. So this is professional grade vision software that's capable of handling all of these cameras we have attached to it. And then we're using a plugin. So we're using an open source plugin to knit together all of that data into the 4D Gaussian splat. This is really the strength of our software, the ability for creators to take third-party apps, third-party software, and integrate it with Emergent's technology. We're grading this 4D Gaussian splat in real time at about 2 frames a second. If we record and then we post-render that, we can go many times that in terms of the frame rate. The whole backbone is GPU accelerated. So this is being run on 2 servers, each with 2 RTX 6000 Pro GPUs from NVIDIA, the latest Blackwell architecture. The GPU is the most efficient way of creating content like this. If we try to send data from 36 cameras into a CPU or the CPU's or the computer's memory, it's not going to work. We need to send it to the most efficient resource, and that's GPUs, which the world is getting very used to in the age of AI. Technology like this is being deployed in a variety of industries, but they're all related to entertainment in some way. So primarily in virtual reality, where you'd capture real life situations and put them into VR goggles. You might have noticed an advertisement where suddenly the perspective shifts, it locks in on the expression of someone's face. That's a Gaussian splat that's being used. It was captured by a lot of cameras and then edited into something really compelling. For the first time this year at NAB 2026, we're showing a new series of Zenith 100 Gigi cameras. So what does that mean? It means new sensors from Sony. We're going up to 105 megapixels and up to 811 frames per second. These are really excited Sony Pre-GS sensors that have come out, and we've integrated them into our Zenith platform. We want to show off how incredible these new cameras are, and we're doing it with an NVIDIA DGX Spark. This has the latest Blackwell AI architecture, and so with a little computer, we get a lot of power. The demo that we're doing involves an open source deep learning algorithm. So we can essentially locate people, see where their limbs are, and how they're moving through the space. The demand for technology like this is coming from a number of places. Sports is a big one. We all want to see how athletes move, how fast they're going. We want to see every bit of their motion. So sports analytics companies, the leagues, broadcasters are seeking out things like this. Even the teams, in terms of injury prevention, are looking at this. Another area where they're looking to use high frame rate, high resolution cameras like this is in immersive content. So they're looking to create immersive theater experiences, new types of entertainment where they can capture at higher resolutions and then manipulate the footage more to get to the final product that they're looking for. In this case, there's not a lot of setup that goes into a markerless application. We're just focusing a camera using a deep learning algorithm on a space. And so if you're looking for simple, this is really it.